Hello and welcome to this GCSE Science additional chemistry revision video on the rate of reaction. In this video we will cover measuring the rate of reaction, factors affecting rate of reaction, endo and exothermic reactions, and reversible reactions. The rate of reaction can be measured by the rate at which a reactant is used up or the rate at which a product is formed. The temperature, concentration, pressure of the reacting gases, surface area of the reacting solids, and use of catalysts are all factors which affect the rate of reaction. Chemical reactions can only happen if the reactant particles collide with enough energy. The more frequently particles collide, the greater the proportion of collisions which will have enough energy, so therefore the greater the rate of reaction. There are two ways to measure rate of reaction as previously stated. We can measure the rate at which reactants are used up, or we can measure the rate at which products are formed. The measurement itself depends upon the nature of the product or reactant. The mass of a substance, solid, liquid or gas, is measured with a balance. The volume of a gas is usually measured with a gas syringe or sometimes an upside down measuring cylinder in water, or a burette can be used. The rate of reaction can be increased by increasing the temperature. The concentration of a dissolved reactant is increased. The pressure of reacting gas. Solid reactants can be broken up in small pieces, or if a catalyst is used. The graph shows how the rate of reaction is faster if the line is steeper. For a chemical reaction to occur, the reactant particles must collide. Collisions with too little energy do not produce a reaction. The collisions must have enough energy for the particles to react. The minimum energy for the particles to react is called its activation energy. This graph shows activation energy in a reaction. The energy level of the product is lower than the energy level of the reactant, so therefore heat or energy will be given out. However, to get the reaction going, we must start by putting some energy into it. The amount of energy that you need to put into a reaction to get it going is called its activation energy. There are a number of factors that affect rate. If the concentration of a dissolved reactant is increased, or the pressure of the reacting gas is increased, if there are more reactant particles, this causes more reactant particles in the same volume, so there is a greater chance of particles colliding, so the rate of reaction increases. If the solid is broken into small pieces or ground into a powder, its surface area is increased, so more particles are exposed to each other to react, so there is a greater chance of the particles colliding, so therefore the rate of reaction increases. If the temperature is increased, the reactant particles move more quickly. More particles have the activation energy, or greater energy. The particles collide more often, so therefore there is more collisions, so a greater chance of a greater rate of reaction. Catalysts increase the rate of reaction without being used up. They do this by lowering the activation energy needed. With a catalyst, more collisions result in the reaction, so the rate of reaction increases. Different reactions need different catalysts. Catalysts are important in industry as they reduce costs. A catalyst is a substance that can increase the rate of reaction without being used up, so it's unchanged. Only a very small amount of catalyst is needed to increase the rate of reaction between large amounts of reactions. In this graph, you can see how a catalyst lowers the activation energy required in a reaction. When a chemical reaction occurs, energy is transferred to or from the surroundings, and there is often a temperature change. For example, when a bonfire burns, it transfers heat to the surroundings. Objects near the bonfire become warmer. The temperature rise can be measured with a thermometer. In exothermic reactions, these are reactions that transfer energy to the surroundings. The energy is usually transferred as heat energy, causing the reaction mixture and its surroundings to become hotter. Temperature increase can be detected. Examples of this are burning, neutralization reactions between acids and alkalis, and the reaction between water and calcium oxide. In endothermic reactions, these take energy from the surroundings. The energy is usually transferred as heat energy, causing the reactant mixture and its surroundings to get colder. Examples of this are electrolysis, the reaction between ethanoic acid and sodium carbonate, or thermal decomposition. Many reactions, such as burning fuels, are irreversible and they go to completion and cannot be reversed easily. Reversible reactions are different. In a reversible reaction, the products that react to produce can go and reproduce the reactants again. When writing chemical equations for reversible reactions, the usual one-way arrow is not used. Instead, two arrows are used that go in both directions. This can be shown as an example below, where ammonium chloride will break down into ammonia plus hydrogen gas, but then the ammonia and hydrogen gas will reform to make ammonium chloride. If a chemical reaction happens in a container where one or more of the reactants or products can escape, you have an open system. If a chemical reaction happens in a container where none of the products can escape, then you have a closed system. Reversible reactions that happen in a closed system eventually reach equilibrium. At equilibrium, the concentration of reactants and products do not change, but the forward reaction is the same as the backwards reaction. So remember, start revising earlier, use a variety of different techniques, turn off distractions, and quality revision is better than quantity of revision. Good luck with your chemistry exams.